You can do the same technique on question number 36. And so let's write down the formulas. Check your work. Potassium phosphate is K3PO4 because phosphate is -3 and potassium is +1. Remember to leave room in front of each formula for the coefficient. You might need that room. Magnesium chloride is MgCl2. Why? Because magnesium is +2 and chloride's -1 each. And here are the products. Magnesium phosphate. This is the most difficult to figure out because magnesium is +2 and phosphate is -3. Therefore, the formula of magnesium phosphate is Mg3 parenthesis PO42. You need 2 phosphate groups to be involved with the 3 magnesiums. And finally, potassium chloride is KCl. And remember, we're going to start counting in groups. In question number 36, there's only one group to keep track of, and that would be phosphate group. We're going to count the phosphates as a group. And how do you try to remind yourself that you're going to count it in a group? On your paper, you should circle or put a square or a box around the groups so that you realize that you're going to start counting in groups. Remember, this technique is called counting polyatomic ions as a group. Therefore, how many K on the left side? 3. How many K on the product side? 1. Now we're going to count the phosphates as a group. That's why I told you to put a circle around it. How many groups are on the reactant side? Go ahead. 1. And on this side, how many groups? 2. There are 2 groups. That's what that 2 outside the parenthesis means, right? How many magnesium on this side? Now it becomes a little easier. 1. Magnesium on the product side, 3. How many chlorine on the reactant side? 2. Chlorine on the product side, there's 1. All right. Technically, you can start anywhere you wish. But for the sake of this argument, here's what I'm going to do. I'm going to tell you that I'd like to balance the phosphates first. See? Because after all, we're here to learn how to count in groups. By the way, you can start anywhere. I just decide for now I'm going to start with the phosphate groups. How am I ever going to balance the phosphate groups? I need to put a coefficient here. And the correct coefficient there is 2. By putting a 2 there, I increase the number of phosphate groups to 2, and I can put a check mark right there. You see that? But what does that do to the potassium? Makes it 6. But you're not going to panic because you know what to do. You know that if you place a 6 in front of potassium chloride, that brings the potassium up to 6, and you can put a check mark next to potassium. But now you're going to panic. You're like, wait a minute. That means there's 6 chlorides. But as I said, you're not going to panic. You know why? Because you can put a coefficient in front of magnesium chloride. You can put a 3 in front of that because that brings the number of chlorines up to 6. But what does that also fix? It fixes the magnesium, and we didn't even mean to fix that at that point. So here's the balanced equation. 2 moles of K3PO4 react with 3 moles of magnesium chloride, and this produces 1 mole of magnesium phosphate and 6 moles of potassium chloride. What made this a lot quicker to do is that we counted the phosphates as a group.